JK flip-flop. Okay, we know already SR flip-flop. So to avoid that two states problems, one is no change, another one is the indeterminate. We are implemented D flip-flop. Okay, happy. Okay, D flip-flop always it is going to provide whatever the input, the next state same input is going to produce. You have that. So now one more flip-flop they are implemented, JK flip-flop. Now we are going to design the JK flip-flop. So what it contains? Simple. In place of the indeterminate state, we are going to add the toggle state. You convert that indeterminate state into toggle state. Means the JK flip-flop also same like SR flip-flop. SR flip-flop contains 4 states. Same 4 state will come here also. But one thing you need to change. What is that? That indeterminate state you should convert into toggle state. So what is this toggle state? Toggle state is nothing but a complement state. Toggling is nothing but a complementing. Whatever the output will come, you should implement as a complement. So that is extra in a JK flip-flop than SR flip-flop. So even the circuit diagram also same. Only one toggling line we need to do extra. Are you clear? That is what I told you in the first class. If you know JK, latch, SR latch, all are following same. Okay. Indeterminate condition in SR flip-flop. Indeterminate condition in SR flip-flop, we are going to use in JK flip-flop. We are going to use in JK flip-flop by changing indeterminate by changing indeterminate state to toggle state. Indeterminate state to toggle state. So in JK flip-flop, we have the 4 states. Out of that, one state is a indeterminate state. That indeterminate state you try to convert into a toggling the state. Are you clear? So again here also you will get 4 states. No change, set, reset. In place of indeterminate, we are going to do it toggle. So just observe, this is what type of flip-flop it is? SR flip-flop. SR no. So in this SR flip-flop, one change I told you. What is that? Toggling of indeterminate state. So how to toggle in this indeterminate state? Only very simple. So whenever we are taking back track from QN bar to this SR, are you following? Just this line you take it as an input for your clock. So this is toggling. Now the SR is going to convert JK. So only toggle lines we are going to take extra in your circuit of SR flip-flop to JK flip-flop. Only why? What is the intention of JK flip-flop? The intention of JK flip-flop is the indeterminate state converted into toggle. That is only the change. That is why the toggling lines we are going to use in this SR flip-flop to convert it into JK flip-flop. Clear? Flow is required. If you are there in the beginning of the class, then you can understand what I am doing. Clear? Yeah. Then this is a logic circuit. Anyway, you know Qn plus 1. Qn plus 1 is a next state. Present state, next state, and present current input. Again, I am repeating my statement. The sequential logic circuits output always depending on the present input and present state. Correct. This you know already. I don't want to tell always. You know, this is a present state. This is a next state. Yes, these are the present inputs. Got it? Got it? Then how to design a truth table? Truth table. Already you know. What are the variables you need to consider? Truth table input variables. Always output depending on current input and current state. Present input and present state. What is the present input? J, K. Clock always on. I don't want to discuss much here. J, K. Next. What is the present state? Qn is the present state. Then next one. Next state is Qn plus 1. Present state is Qn. Correct? Now tell me, you know, the possibility 0, 0, 0, 1, 1, 0, 1, 1. For all these cases, we don't know the present state. Then what is the present state? Do not care condition you should take. Correct? Yes or no? Yeah. Then you need to calculate next state. Correct? How to calculate next state? Tell me. The first case. What first case? J equals to 0, K equals to 0. So, Qn plus 1 equals to, what is the Qn plus 1? Tell me. Now, this is 0. In this case, this is 0. Correct. Clock always, it will represent 1. Correct. Because clock must be in a same pulse. Means both complement and direct, same pulse. So you go to latch a different pulse. That is why the behavior is different. If it is 0, it will produce 1. That is why we are not considering clock in a latches. That difference you should be remember always. 1. So now same clock. If the clock is 0, circuit is off. Simple. So now always our circuit is on, only we can calculate anything. Switch is on, only your fan will be rotated. Yes or no? Yeah, that is a clock, a digital clock. Now tell me, here now what we are calculating here? Qn plus 1. Now 0, 1. 0 into 1, how much? 0 into 1, 1. 0. 0 complement 1. Now we are here. Okay, then calculate the Qn plus 1. Yes, tell me, what is the Qn plus 1? 1 into, this is 1, then, see this, Qn bar. Then, after this, complement. Then what is going to happen? 1 into Qn bar. What is happening here? Huh? Qn bar, whole bar. What is going to happen here? Qn. Okay. But J equals 0, K equals 0. Maybe there is a scope. J equal to 0, K equal to 0. In this case, you should be go with the complement line also, as we have discussed in the last class. Correct? Yeah. Then go with the complement line. Qn plus 1. What is going to happen here? Again, 0, 1. 0, its complement is 1. Okay. Now same, here also same, you will get 1 into Qn whole bar. Then what you are going to get here? Qn bar. means it is a no change condition. Are you following? So this is a no change condition. Got it? Because Qn plus 1 we are getting Qn. Qn plus 1 bar you are getting Qn bar. So it's a no change condition you are going to take as a Qn. Clear? Then coming to second phase of verification. What is that? J equals to 0, 1. Anyway, clock always 1. You should consider 1. So now do it. Again, Qn plus 1 equals to, anyway J equals 0. After this, you will get 1. So 1 into Qn bar, whole bar. You will get Qn. Already, that state is already existing. So there is a chance in a complementary line. Yes or no? So go with the complementary line. So what is going to happen here? Here I think k equal to 1. 1 into 1. So the complement is 0. So now what is going to happen here? 0 into Qn whole bar. So 0 bar. So 1. Qn plus 1 is 1. So with reference to Qn plus 1 bar equals to 1, then we can take Qn plus 1 equals to 0. So now 0. 0 is a set or reset. Reset condition is fulfilled. Our aim is, what is our aim? In this JK flip-flop, you should toggle it off indeterminate state. Okay? Then coming to third. Because procedure is same, like SR flip-flop, what we have done, JK have same. One change, that is what I told you. You remember starting, your answers are clear. Okay, please. Now tell me, J equals to 1, K equals to 0, right? Now do it. Kn plus 1. So J equals to 1. So 1. 1, 1, 1. Complement is 0. Then 0 into Qn bar, whole bar. Then 0 bar. Then 1. Then no need to check its complement line because Qn plus 1 is 1. Nothing but a set state. Correct? Correct? Yeah. No need to complement line. Then J equals to 1, K equals 1. Compulsory we need to do both because J and K is pointing same value. Correct? This is the scenario you can understand. Then tell me, sorry. Yeah. Qn plus 1. Now in this case, Qn plus 1. What happened? Tell me. J equal to 1, its complement 1, 1, 1, complement is 0. 0 into whole bar. What is going to happen? 0 bar, 1. But already the set state already existing, right? And you need to check with its complement line because J equal to 1, K equal to 1. So it is not possible actually, but it is there. So we need to check. So Qn plus 1 complement. What is going to happen here? Again 0 into Qn whole bar. What is happening? 1. So actually this is what? Indeterminate state. Our aim is to avoid the indeterminate state in a JK flip-flop. Correct. So in this case, what we need to do? In this case, what we need to do? So this case, Qn plus 1 equals to what we need to do? Here, just observe here. Qn we are doing, then what is going to happen? Just come to the line. So here, I will take red. So Qn calculation. This is your connection, correct? Then what you are calculating? You are calculating Qn. Yes or no? So what we are going to calculate in this case? Just yellow line, observe. Right. Now what is the input here? 1 into 1, 1. Yes or no? One into. Now what is this? One more input. Just check this. QM. Then all bar. What is going to happen? QM bar. Understand? If you do same way for QN plus 1 bar, again, what we need to take? 1 into 1, 1. So you need to take your toggle line, not straight line. Toggle line you need to take. Toggle line. Here we are calculated up to this one. Now you need to take toggle line for this. Same like how we are going to done. How we are going to done? Tell me. One more color I will take. Again yellow. Got it? Toggle line you choose. So in this case, what is going to happen? Again, 1 into QN bar, all bar. What is going to happen? QN. So now toggling. Toggle is happened. What is that? In place of indeterminate phase, because of toggle line, to avoid this situation, this is the toggling. What I told toggling? What I told toggling means? Toggling means what I told? Complementing. Now just get Qn plus 1 is a Qn complement. Qn plus 1 complement is a Qn. So Qn is there. What you are going to get? Understand? Understood? Here this is a JK flip-flop. This is a JK flip-flop. To avoid indeterminate state, to add a toggling, we are going to add toggling lines to connect your circuit. Now this is a no change condition. This is a reset condition. This is a set condition. This is a toggle condition. Got it? Clear?